So today we're going to be learning about what chemistry is, and that's chapter 1. This video is going to be quite short since this is a really straightforward chapter and is really for breaking you into how the class works and what you're going to be expecting in the future. So chemistry is the study of the composition of matter and the changes that matter undergoes. And as you all know, matter is anything that has mass and takes up space. Chemistry affects all aspects of life and most natural events because everything is made up of matter. So, in the world, this is a very important science, and it probably has impacted all of us. The 5 branches of chemistry are organic chemistry, also known as carbon chemistry, inorganic chemistry, biochemistry, analytical chemistry, and physical chemistry. Organic chemistry is sort of separated from the other chapters this year, but you will learn about it. And it is a very important branch of chemistry if you decide to go into medicine. Organic chemistry is a very intuitive and straightforward concept if you learn about it. So, if you take the time, I actually quite enjoyed it when I did organic chem. And then inorganic chem is actually the bulk of what we're going to be doing this year. And inorganic chem is the study of chemicals that generally don't contain carbon. So that's literally everything else. And that includes water, or salt, NaCl, or rust. And as you will come to know, sodium will be a very important element this year and actually will be an element present in a lot of your reactions when you get to those chapters. Biochemistry, we don't really get into too much, if not at all, because it's simply about processes taking place in living organisms, and for example, muscle contraction, digestion, or exchange of chemicals between your nerve cells, so on and so forth. And we don't really go into that at all. Analytical chemistry is the study of the composition of matter. An example is testing the air for pollutants. And this is sort of what we go into this year. The main focuses are inorganic and a little bit of physical chemistry, but analytical chemistry exists in all those. You need to know what things are, and especially in titrations, you'll also begin to figure out um, what kind of compounds are in a solution. So, and then lastly, there's physical chemistry, and that's the study of energy transfers that occur when matter changes. So that's more like chapter 17 type of work, and um, it's very different from what you are going to learn in reactions, but it's related. And most of this, all chemistry is very straightforward, intuitive. It just takes time and a little bit of effort, and you'll be able to understand it pretty well. The main types of chemistry are pure chemistry and applied chemistry. Pure chemistry is the pursuit of chemical knowledge for its own sake, and that can be compared to space expeditions or treks into caves. We really don't know what this research is going to produce. It's just we're researching because we can. And although it's not uh, aimed at producing a certain solution to a problem, it often makes a solution to a problem. Like when we went into space for the first time, we discovered ways to use different medical equipment and new ways of communicating over long distances, and that was just from going into space. So that is a very important aspect of pure chemistry. It is not for the sole purpose of finding discoveries or solutions, but it can end up finding them on accident. And applied chemistry is research that is directed toward a practical application. So this research is like finding the cure for cancer, for instance, and it is very focused on what you're trying to do. And often, pure chemistry finds solutions for applied chemistry. So um, both are very important types of chemistry, and I think you'll be finding that you'll use applied chemistry more this year because your teacher will often give you problems that have solutions already. And then the way we'd be able to advance our knowledge is through technology, and that helps provide society with the things that are needed and desired. So, for instance, if we couldn't look far enough into space, we'd use a telescope. If we wanted to compute faster, we'd use a computer. Things like that. And the more we use technology, the more we are able to advance our knowledge. It's just a cycle that keeps repeating over and over again. The more we research, the more technology we find out, and the more technology we find out, the more research we do. So it's an infinite cycle of how much we can discover about the universe. And lastly, there are a few reasons why you should study chemistry and 4 results of modern chemistry research. Chemistry helps us understand natural phenomena, prepare for a career, and become educated citizens. The 4 results of modern chemistry are benefiting the environment, conserving and producing energy, improving human life, and expanding the knowledge of the universe. And all of these are self explanatory, um, and except for maybe becoming educated citizens, because by learning the natural phenomena, we can come to understand the world more in a profound way, and help us help us prepare for intelligent conversation with other people about why things happen, or uh, what is that, or how something works. And modern chemistry, there's nothing truly horrible that could happen from it. That concludes the first video for chemistry. Um, I hope that it helped you a lot, and I wish you luck on the rest of your chemistry endeavors and careers.